Linked into the content pages on Learning Suite, where the web page that I got all these illustrations from. So now it does a collection phase. What do you notice? Look at the free memory.
It's kind of patchy.
Yeah, it's patchy. It's fragmented. You've all heard the term fragmentation for like disks and other things. Memory can be fragmented. In other words, these blocks are still in use. All these black ones are free blocks. What if I wanted to allocate, imagine this process continued all the way down to the end. What if I wanted to allocate one big free block, and there's plenty of total free space available, there's just no one slot that's big enough anymore. And so the memory allocation will fail. You can have a system that will fail even though there is plenty of free memory to satisfy that. Sorry, you have a system where a large memory allocation can fail because even though half your memory is free, there's not a single free block big enough to satisfy that request. And this is a real issue with memory management systems, yeah.
Isn't that what virtual memory is for?
Except the problem is now what would happen is I've got something in RAM, but I'm really only using half of it. And so yes, I might actually page out to virtual memory, but now remember, virtual memory might actually start paging stuff in, and so I'm going to get unnecessary paging of pages in and out. You've heard the term thrashing, right, in terms of virtual memory? Even when it might not be necessary. So I might have twice as many virtual pages as necessary because each one's only really being halfway utilized. And half actually underestimates it. You could actually have something that's fragmented with only 10% utilization. So there's always a cost with virtual memory because disk accesses are incredibly slow compared to actual RAM accesses. So it's a good point. Most of these systems will actually try to work in harmony, recognizing there might be some virtual memory that the OS is doing. But you really want to try to manage what you have in memory as well as possible. All right, so problems. The first big one is fragmentation. Okay. The second one is the cost of it is proportional to the size of the heap in terms of when people in in memory management systems talk about size of the heap, they're really talking about number of objects, not amount of bytes. And so the cost is proportional to the number of objects in the heap because I have to go through and I have to mark them all as cleared. I have to traverse out and mark them, those that are reachable. That part's only proportional to the amount of live data. But then I've got to go through and sweep and collect. The sweep phase visits every single node and says, are you marked? Great. You're not marked? Go. And so it has to actually visit every single allocated block of memory, or every previously allocated block. The other thing is, think about that now. You are visiting every single block of allocated memory. Have you ever heard of, so you guys are familiar with virtual memory, right? And you're familiar with the idea of locality of reference? That in a program, you're typically working in a typical part, which is why you're typically working in one area of the memory and stuff, and that's why cache systems can work. Well, every time it has to do a memory management garbage collection sweep, you are visiting every block in your entire memory, and you can completely kiss your memory cache goodbye, right? Because you just totally thrashed the entire, you guys know that there's RAM, but then you have like your L1, your L2, your L3 caches above that. Those basically get completely flushed. They're useless after that point, until you start rebuilding based on locality. And so it totally thrashes all your memory caches. It also can thrash virtual memory. If this is, so going back to the earlier point, if we have multiple pages some pages that have been paged out, well guess what? I'm going to go visit those and force the OS to page them in, even if that block of memory out there has not been used in hours, okay? Or days if it's a long-running program. But I'm going to force it to get paged in, and by the way, when it pages something in, something else is going to get paged out. Okay. All right. So we'll wrap up with here. One other idea, though, that we're going to start with next time is, what if I try to actually start compacting and moving memory around? You've run disk defragmentation programs, right, at some point, I assume? Let's do the same thing, and the idea is move it around so the fragmentation's reduced. We can do the same thing in memory. Now, this is going to be an odd idea, which is why I'll just let you think about it next time. How can I, as the language, move stuff around on you and still have everything work?